The atmosphere, weather and climate. The blanket of air surrounding the Earth is known as the atmosphere. Without air, Earth would have been a lifeless planet. It not only supplies air and water to the plants and animals, but also protects them from the harmful rays of the sun. The atmosphere stretches above the Earth to a height of more than 1,000 kilometers. It is held in place by the Earth's force of gravity. Gravitational forces are stronger near the surface of Earth, and therefore the density of air is greater near its surface. As we go higher, the air starts thinning. Ultimately, it merges with space. Composition of the atmosphere. Air is a mixture of several gases in different proportions. The composition is nitrogen 78%, oxygen 21%, other gases 1%. Some dust particles are also present in the atmosphere. Nitrogen, the most abundant gas, is useful for the survival of plants. Atmospheric nitrogen is converted into nitrogen compounds by nitrogen-fixing bacteria present in the soil. Plants absorb nitrogen compounds and convert them to proteins. Animals take in proteins by eating plants or other animals. Nitrogen returns to the atmosphere when denitrifying bacteria act on the animal wastes and the dead bodies of plants and animals. Oxygen ranks as the second most plentiful gas in the atmosphere. It is essential for the survival of plants and animals. Living beings need this oxygen to breathe and stay alive. Green plants produce oxygen during the process of photosynthesis. Carbon dioxide is used by the green plants for making food. So, the carbon dioxide used during photosynthesis is replaced by the carbon dioxide released in the respiration by the organisms. Thus, nature has ways of maintaining a balance of gases in the atmosphere. However, human activities are disturbing this balance by polluting the air. Structure of the atmosphere. The atmosphere can be divided into 5 distinct layers: troposphere, stratosphere, mesosphere, ionosphere, exosphere. Troposphere. The lowest and the densest layer of the atmosphere is known as the troposphere. About 3/4 of the mass of atmosphere is contained within this layer. This is the sphere in which changes related to weather conditions occur. It protects us from the heat of the sun during the day and keeps the earth warm at night. The extent of this layer is about 18 km above the equator, but only 8 km above the 2 poles. Most of the water vapor, dust particles, and clouds are found in this layer. The upper limit of troposphere is called the Tropopause. Stratosphere. It lies above the troposphere and extends to about 50 km above the Earth's surface. There is a gradual increase of temperature in this layer. This is the layer in which air travel is safest because there are no bumpy pockets of air. Therefore, aircrafts usually fly in this sphere. It also has a band of ozone gas which protects us from the sun's ultraviolet rays. It is called the ozonosphere, which is quite warm due to absorption of these rays. Mesosphere. It lies above the stratosphere and extends to about 80 km above the Earth's surface. Here, the temperature decreases with height till it reaches -100 degrees centigrade. This layer has the lowest temperature in the atmosphere. Meteors entering the atmosphere usually burn up in the mesosphere. The upper limit of this layer is called the mesopause. Ionosphere. It lies above the mesosphere and extends up to a height of about 400 km above the Earth's surface. It contains electrically charged particles called ions, which help in transmitting of communication signal. Radio waves are reflected back to the Earth from this layer. Communication satellites help in transmitting the signals back to Earth. The temperature rises rapidly with altitude in this layer. Exosphere. The outermost layer of the atmosphere is called the exosphere. The air thins in this sphere until it ultimately merges into outer space. The temperature increases rapidly in this layer because of the solar radiations. Weather and climate. The terms weather and climate are very closely related to each other. But weather should not be confused with climate. Weather can be defined as a particular condition of the atmosphere prevailing over a small area at a particular period of time. Weather is dynamic and changes within a short period of time. When we speak of climate, we mean the average atmospheric conditions of a particular area. So, climate can be defined as the sum total of all the weather conditions prevailing over a large area over a considerably long period of time. The climate stands for a generalized picture of the weather conditions of a given place. Hence, the elements of weather and climate are the same. They are temperature, pressure, wind speed and direction, humidity, precipitation, sunshine, etc. We usually get information about the weather from weather reports and forecasts published in newspapers or broadcasts over radio and television. Let us now learn about some of the elements that determine weather and climate. Atmospheric temperature. The sun is the main source of heat and light for the Earth. It radiates energy in all the directions. Being far away from the sun, the Earth receives only a very small fraction of this energy. The solar energy received by the Earth is called solar insolation. This insolation is the driving force to heat the Earth's atmosphere. This insolation varies from place to place. More insolation is received on and around the equator and much less on the poles. On the basis of sun heat received by the Earth, we may divide Earth into following heat zones: the Torrid Zone, the Temperate Zone, and the Frigid Zone. The figure depicts three distinct temperature zones. The Torrid Zone lies between the Tropic of Cancer and the Tropic of Capricorn. Here, the sun's rays are almost vertical throughout the year. This zone receives the maximum heat and is the hottest zone of the Earth. The Temperate Zone lies between the Tropic of Cancer and the Arctic Circle in the Northern Hemisphere, and between the Tropic of Capricorn and the Antarctic Circle in the Southern Hemisphere. In this zone, the sun's rays never fall vertically. They are always oblique. This zone is neither too hot nor too cold. The Frigid Zone lies to the north of the Arctic Circle in the Northern Hemisphere and to the south of the Antarctic Circle in the Southern Hemisphere. Here, sun's rays are very slanting. This zone receives very low amount of heat. Hence, this is very cold part of Earth. Heating and cooling of the atmosphere. The temperature at a particular place does not remain constant. It varies with the time of the day and year. Sun is the only source of atmospheric heat. But the atmosphere absorbs very little of the sun's radiation. Solar radiation heats the ground first. From the ground surface, the heat is transferred to the atmosphere through these processes. Radiation. Radiation is the direct heating of an object by the transmission of heat waves. The atmosphere absorbs very less amount of incoming solar radiation, but absorbs heat radiated from the Earth's surface. called terrestrial radiation. Conduction. This is the transfer of heat through contact. A cooler body comes in contact with a warmer body and gets heated. When the lower layer of atmosphere, which is in touch with the ground, comes in contact with the upper layer, the heat particles move from lower to upper layer. Thus, the atmosphere is heated gradually upwards. Convection. When the air gets heated and becomes lighter, it starts to rise. This process of transfer of heat is called convection. The rising air currents are called convection currents, and as they rise, they keep transferring heat from the lower layers of the air to the higher layers. Advection. When the wind moves from warmer region towards a cooler region, it increases the temperature and vice versa. The temperature of the atmosphere cools down or heats up due to the horizontal movement of the wind. Factors affecting temperature. Temperature varies from place to place on our Earth. There are some factors which control the distribution of temperature on the surface of the Earth. Latitude. The angle of incidence of sun rays is not the same everywhere due to the spherical shape of the Earth. The angle of incidence is high on and around the equator, and it goes on decreasing towards the poles. This is the reason why places near the equator have a high temperature, and as we go towards the poles, the temperature goes on decreasing. As we move away from the equator, the sun rays become increasingly slanted. This spreads out the heat over a larger area. Altitude. As we go and up higher, we would feel cooler. This is because atmosphere is heated indirectly by the heat of the Earth. So, the places at lower altitude or plains are warmer, and as we go height towards up to a mountain, it becomes increasingly cooler. This explains why Nainital is always cooler than Delhi. Distance from the sea. The places near the sea or any large water body never experience extremes of temperature. They always remain mild or moderate. Such a climate is called maritime. The places that are away from sea experience extreme of temperatures. These places have a climate called continental or extreme. For example, Mumbai has a maritime climate while Delhi has a continental climate. Ocean currents. A stream of water in an ocean flowing in a constant direction is called an ocean current. They make considerable difference in the temperature along the coastal regions. The warm ocean currents along the coast help to increase the temperature, while the cold ocean currents help to decrease the temperature in a coastal region. This is the reason why the cold Labrador current affects the eastern coast of Canada, and the Canadian coast remains frozen during the winter. Similarly, on the western coast of Europe, the warm North Atlantic drift melts the ice during the winter and keeps all the ports ice-free throughout the year. Winds. A constant wind blowing across a region tends to change the temperature of that place. If a wind is blowing from a colder area, then the temperature will be reduced. For example, if Delhi receives wind from the Himalayas, it will experience cooler temperature. On the other hand, if it receives hot winds from Rajasthan, then it becomes hotter. Vegetation cover. The forest cover absorbs much of the heat received from the sun. Thus, the desert area having no vegetation gets heated more quickly during the day, and at night it releases the heat and gets cooler quickly. The nature of the soil and slope of the land are other factors which control the temperature of a place. Measurement of temperature. Temperature is measured by an instrument called thermometer. A thermometer is a narrow glass tube which is graduated and filled with mercury or alcohol. It works on the principle that mercury expands when heated and contracts when cooled. The expansion and contraction of mercury in a calibrated tube indicates the temperature. We use two different scales, Fahrenheit and the Celsius scale. On the Fahrenheit scale, the freezing point is 32 degree Fahrenheit and the boiling point is 212 degree Fahrenheit. On the Celsius scale, the freezing point is 0 degree centigrade and the boiling point is 100 degree centigrade. The temperature on one scale of measurement is converted to another by using the formula C upon 5 is equal to F minus 32 upon 9. Trivia. Some other kinds of local winds and their nature comes in: hot, dry wind in Egypt, sirocco, hot winds from Sahara to Mediterranean Sea, blizzard, very cold winds in tundra region, Santa Ana, hot wind in South California in USA.